In this lesson on sequences and series, we're going to have a look at the geometric series. In lesson 5, we already proved the sum formula for a geometric series. Now we're going to have a look at how to use it. So, just like with any other formula, there are 4 variables. So you'll always have A, our first term. Then you'll have, in this case, R, but also D if it's an arithmetic series. N for the number of terms, and then Sn or Tn depending on what you are calculating. So there will be 4 variables, 3 will be given in some way, and you need to calculate the 4th. So let's have a look at example 1. Calculate the sum of the following series: 2, 6, 18 up to 10 terms. So they do not tell us what type of series this is. So we are going to have to determine whether it's arithmetic or geometric. Now, if you look at the difference, there's no constant difference because we add 4 and then we add 12. But there is a constant ratio because we multiply by 3 every time, meaning this is a geometric series. So we already know that A, our first term, is 2. We calculated the constant ratio as 3, and we know we want to get the sum of 10 terms. So now we can calculate Sn using our formula. So all we need to do now is substitute into our formula. So we are going to get the sum of 10 terms. A is 2, our constant ratio is 3, and once again 10 terms. And we're going to divide that by 3 minus 1. And this you can do on your calculator and you will get 59,048. Let's have a look at example 2. Calculate the sum of the following geometric series. So this time they are mentioning that it is a geometric series. So we know that somewhere we will find a constant ratio. To calculate this constant ratio, we're going to say term 2 divided by term 1. So minus 9 divided by 27 will give us a constant ratio of minus a third. We also know that A, the first term, is 27. Now if we're going to have a look at our sum formula, we need A, R, and also N, which we don't know. If you go and look at the information, you will see that we know the value of the last term. So that means we know that Tn is 1 over 2187. And therefore, we're going to start off using the Tn formula for geometric sequence first. And we're going to use that to calculate the number of terms. So let's start substituting. Tn is 1 over 2187. A, our first term, is 27, and R, our constant ratio, is minus a third. I'm going to start off by dividing by the 27 on the left to get 1 over 59,049. And now, because I want to solve n in the exponent, I once again need to get my base numbers the same. So I want to rewrite the left as minus a third to the power of something. Now you can once again use your calculator to write 59,049 in terms of prime numbers, and your calculator will tell you that that is 3 to the power of 10. So I'm going to say minus a third to the power of 10 is the same as 1 over 59,049. So now I know that the bases are the same, which means the exponents are the same, so n is 11. And now that I know n is 11, I can go and calculate the sum of 11 terms. And to do that, I substitute in. A is 27, my constant ratio is minus a third, and in the denominator again minus a third minus 1. And when I calculate that, I will get 20,25. Let's have a look at example 3. Consider the following geometric series. How many terms of the series should be added to get a sum of 20,475? Now, once again, they mention that it's a geometric series. So we are going to calculate R, the constant ratio, by dividing term 2 by term 1. So we have a constant ratio of 2. We also know the first term is 5. And in this case, we need to calculate the number of terms, but we know that the sum is 20,475. So now we go and substitute into our sum formula. We know the sum should be 20,475. A is 5, the constant ratio is 2, and we divide that by 2 minus 1. So now I can go and simplify my denominator to 1. And next I need to divide by 5 on the left to get rid of the 5, and that will give me 4,095 on the left. Now I'm going to get the 2 to the power of n alone by adding 1 on the left. And now once again I need to get the bases the same, and 4,096 is the same as 2 to the power of 12. And that means when I add 12 terms, I will get a sum of 20,475.